Hey, what's up, guys? I want to go over this really quickly with you because I think I confused the heck out of a lot of you today, specifically in fourth and fifth hour. I'm going to kind of break this down and hopefully get you squared away on this. Obviously, the problem with this is if you way overthink it, which is what I did today and confused myself, and then I think I told some of you wrong. Um, First thing that we need to know that I want you to think about is this situation. So if I have a box, okay, so this box is going to represent the world, okay. In this box, I have a person. Don't mind my drawings. Okay, I got a person. Okay, this person is going to consistently be breathing out CO2. Okay, that is what we breathe out because it is a byproduct of cellular respiration. In turn, we are going to be breathing in O2. So we're breathing out CO2, we're breathing in O2. Over time, if we just sit in this box and there's nothing else in this box, we are eventually going to suffocate and die because we are only breathing out CO2 and eventually we're going to use all the oxygen available. Okay, so just like this, in the real world, if there was nothing that produced O2, that produced oxygen, we would end up as humans dying or animals dying because we would not produce enough, or we would produce too much CO2 and we would not have enough O2 to continue to breathe. So that is why it's important for us to have things like trees. This is an awful tree, but that's a tree. Trees are going to breathe in CO2 and breathe out O2. Okay, so the thing that is important about plants, okay, and this could be plants, this could be algae, this could be protists, plants, or I'm sorry, organisms that do cellular respiration and photosynthesis. Okay, photosynthesis is the key here. Okay, what we need to know about those guys is that photosynthesis rules everything. Okay, so photo, this is going to be hard to write. Photo rules. Rules. There we go. That was a complete waste of time. But photosynthesis is always going to rule. Okay, what I mean by that is photosynthesis is always going to outperform cellular respiration. Plants are going to do photosynthesis far more than they are going to produce CO2. Okay, so it's important for us to have plants and organisms that do photosynthesis because they are going to take in so much CO2 out of the atmosphere to then do photosynthesis and release oxygen. Okay, so when we look at all of these problems here in this table, what we have to remember is that if photosynthesis is occurring, photosynthesis is going to take in a lot of CO2. Okay, so a couple things I want to just go through just to kind of give you an idea of what I'm trying to tell you. So if we have a plant with light in a solution that is used bromo blue, so that means that it's yellow, right? So that is yellow. Okay, so used bromo blue with a plant that has light. This plant is going to do photosynthesis. Okay, so photosynthesis is going to occur. If photosynthesis is occurring, that plant is intaking a lot of CO2. Okay, now that plant is also doing cellular respiration, and it's putting off CO2. But again, photosynthesis rules. Okay, so photosynthesis is going to absorb almost all of that CO2 that is being produced by the plant. Okay, so if that's happening, if photosynthesis is occurring, we can basically say that it is going to pull out all of the CO2 out of the solution. Therefore, this solution is going to change back to blue. Okay, so that's going to change back to blue. Okay, and the reasoning is photosynthesis is happening, which pulls in CO2 at a very, very large or a very fast rate, okay? Because photosynthesis is always going to outperform cellular respiration. On this one, we have new bromo, so that's blue. So that's blue bromo. We have a plant with light. Okay, photosynthesis is going to be occurring because the plant has the limiting factors for photosynthesis. So if photosynthesis is occurring, it's going to be pulling out all of the CO2, which means that the bromo blue is going to remain blue because bromo blue indicates if CO2 is present. Okay, so it's going to stay blue because the plant is doing photosynthesis, which is pulling in all the CO2. Okay, so I'm going to let you figure these two out on your own. Okay, I'm going to jump down to the snails real quick. I don't want to make this too long. So if you have used bromo blue, so again, that's yellow. Okay, yellow. So it's yellow bromo blue with snails, but no light. Okay, so notice there's no plant in here. So the only process that the snail is going to do is cellular respiration. So if it's only doing cellular respiration, it's only producing CO2. If CO2 is the only thing being produced, the used bromo, which is yellow, is going to remain yellow because it indicates the presence of CO2. Now this one, okay, this is new bromo with a snail, with a plant, with light. Okay, this situation is exactly what we drew here. Okay, so imagine my person is a snail. Okay, so I have a plant, I have a snail, and I have light. So the plant is able to do photosynthesis. The plant and the snail are doing cellular respiration, producing CO2. But if photosynthesis is occurring, we know that the plant is going to be pulling in all the CO2. Okay? So it's blue bromo. CO2 is being produced, but the plant is bringing it all in. So therefore, this is going to stay the same. Okay, think about it. That's how we live. That's how we can stay alive because the plants are consistently pulling in CO2 to keep our environment stable for us to breathe oxygen. Okay, so this would be stays. And then the last one here, new bromo, snail, plant, no light. No photosynthesis is occurring because we don't have any light. Therefore, the only thing that's occurring is cellular respiration from both the plant and the snail. CO2 is being produced, changing the new bromo to yellow. Okay, hopefully that helps. If you have any questions over any of this, please let me know. Okay, email me, let me know if you need any help, and I will try to get to you on that. Okay, have a great night.